computer. All right, so this is the form I sent. I'll repeat myself again because I did not start the recording earlier. So this is the form I sent. I expected you guys to fill it. There's general questions here, which will give me a brief understanding about what is it which you already know. And the first question here was, do you know these tools? And as I said, these tools, this is not exhaustive list of all the tools which you must know, but this is a list of tools, which is something you must know before you go to an interview job, job interview, sorry. This is, again, as I said, not exhaustive. There are a hell lot of other things as well, but if you don't know these basic ones, that means we have to start from here. So all in all, the goal of this form was for me to know where to start from, because I don't know where you are, right? So that's the reason I sent this form. So Docker, Jenkins, Kubernetes, Helm, Prometheus, Grafana, GitHub, GitLab. I mean, you don't need to learn all. So Jenkins, GitHub, and GitLab almost does the same. All three does the same thing. GitLab, GitHub, they are a bit advanced. Jenkins is a bit old. Old doesn't mean it's obsolete. Old means it's still old, but still gold. A lot of companies use it. But a lot of companies also started to move to other advanced modern tools, which is GitLab. Any of these tools are good. Either GitHub, GitLab, or Jenkins. Then do you know what is Kubernetes? And Kubernetes, there are multiple things. Kubernetes, one is how do you install the cluster? That's more of an ops part, right? It's creation of the cluster, configuring the cluster, setting up some load balancers if you're using on, and depends on where are you doing that. Are you doing it local? Local is simple, Minikube or kind cluster you can do. If you are on a cloud, then you will go for AWS EKS, or maybe in Azure AKS, or in GCP, different one. But I think Azure and GCP is not in scope anymore for this. That's what I know. That's what I've been told. So let's focus on AWS EKS. So how to set up the cluster is one thing. And second thing is how you will use your release engineering or build pipeline to deploy to that cluster, right? So those are two different things. And that's why we have a concept called as Helm. Helm is there to deploy certain payloads or workload on the Kubernetes cluster. So within one tool, what I'm trying to highlight is within a single tool, you have many things to learn. And we need to focus because you cannot learn everything in 2 months. This is all this, what I'm talking about, people take 2-3 years to understand everything. Okay, so we cannot learn everything within 2 months, 3 months. So we have to start focusing on certain things. What we do is, whatever tool it is or whatever concept it is, we try to focus on something which is of utmost importance. That's something which you must know, and then we try to touch base on other things of that, other aspects of that tool. So we'll try to say, okay, we'll try to go through to the breadth, like what Kubernetes is and how it works, etc., etc. But we also, in terms of experiments which we do, we will be very focused and crisp. So for example, in the case of Kubernetes, we can do experiment where we have a payload, we have let's say 5 or 6 microservices, and we try to write a Helm chart for it where we try to deploy it on a Kubernetes cluster, which is already provisioned in the AWS space. So this is what will be the scope of our experiment. Our experiment need not be that we are setting up multiple EC2 machines and then we are creating our own cluster and then attaching it, and that will take a lot of time. And that will not be maybe much benefit in terms of your job search. Okay. So whatever I said in last 5 minutes, all I was trying to highlight is there are many things to do. There are many tools to learn. But what we have to understand is we don't have to learn all tool, and we don't have to learn everything in detail. What we need to do is to do some certain experiments with these tools, which is something which are the basic experiments. Like if you're saying Docker, how you will write a Docker file so that you can Dockerize or containerize specific application, and how you will push it, and how it will be read by your CI/CD pipeline, and it will go and deploy it in the Kubernetes cluster, something like that. This is our experiment. So we'll try to learn something in terms of experiments. Fine, enough on this point. Now there are other things like serverless. Again, here something on Helm chart, something on Terraform, something where you provision the clusters, provision the services, and all those things into AWS or cloud platforms. This is more of an ops kind of thing, where you use Terraform scripts for deploying things, or Ansible scripts, playbooks for deploying certain things. Then comes the monitoring part, which is again something if you're looking for to become a DevOps engineer or release engineer, then this is also something important. Whatever you are running, whatever payload you are running, whatever you are deploying, you have to have something called as observability. Observability means,
हेलो सर,
yep,
आपकी आवाज नहीं आ रही।
really? And no one said anything? Can you hear me now?
Yes,
Sir,
yes,
Hari,
sir,
Sir,
your
audible.
voice
We
is
can hear you.
audible.
Sir, we can hear you.
Oh, aa rahi hai. Okay,
I
fine.
think that person is having network problem.
So I'm not sure who raised it. So please check your connection or mic or whatever, or maybe speaker. I think the problem with the speaker perhaps. Okay, let me readjust. I think I'm okay now, right? Audible.
Yes,
Okay.
sir.
Okay,
Yes.
thanks.
Yes, you're audible.
Okay, fine, cool. So, okay, fine. Terraform, again, something to do with the, not with the application per se, it's something to do with how you provision a cluster. So as I said, in DevOps space, when you say DevOps, there are two parts to it, Dev and Ops. And Ops is more about clustering, how you set up things, infrastructure as code, this and that. It's primarily to something to do with infrastructure as name says. So Terraform is a thing which you use for infrastructure, right? Infrastructure as code. So it's more about Ops, setting up infrastructure, making sure it runs, putting in some alerts, observability things so that,
हेलो,
you know, yeah, yeah, please speak.
anybody can listen me?
I can hear you.
Hello.
Okay, let me who is this guy? Let me stop my share quickly.
Yes, I can hear you as well.
You can hear, right? So is it Sumant who is asking this or
No, it's
Suman J?
Vinay.
Is Vinay
Vinay.
Mandle.
Can anyone ping him? Maybe on WhatsApp saying we are all able to hear. It's just you who has a problem. So you may try to reconnect. Sorry, you are not audible. Vinay is saying you're not audible. Let me type Vinay. I think issue is at your end. We all are able to communicate clearly. Can you try reconnecting or change the mic or headset? Okay, fine. I'll restart my sharing. Share again. Okay, fine. So this is about infrastructure. And then comes the most important part here, which is the pipelines. Because I think when you, whatever experience level you have, when you go to an industry, this is something like the first thing you are asked to do. That is developing a proper CI/CD pipeline. This comes under a specialized area under DevOps space called as release engineering or build pipelines or CI/CD. It has many names, but it's something to do with build and release engineering, basically, which directly means that you have to create a CI/CD pipeline. And CI/CD pipeline is not entirely straightforward. It has many stages, and under those stages there are two very important things. Rather, a lot of all the stages are important, but there are too many very important things. Something called as compliance. Compliance is where you run tests, different kinds of tests, including SAST, which is
क्या वर्कफ्लो मैं इसमें कोडिंग कर लेवल एसटीपी करेंसी पे होता है
guys, can you please be on mute?
वर्कफ्लो
Okay. Okay, thank you. Whoever was it? Fine. Right. So this is CI/CD, some wherein you have to put a lot of checks, as I was saying, the test, and then you have different kind of tests, right? So SAST is where you do some sonar, then you have container vulnerability checks, and then secret checks, and then test code coverage checks. A lot of checks. This all of this comes under something called as compliance. Compliance is that it's the job of a release engineer to make sure that whatever code developer is writing, he is not able to push it into production without running these mandatory checks, which is called as compliance checks. And this is your job, being a DevOps engineer, release engineer, build engineer, or CI/CD engineer, whatever you wish to call it. It is your job to make sure that you put these kind of compliance checks, and they are something which make sure that bad code is not going into the production, right? So compliance, another thing is called as guardrails. So you have to create some quality checks, quality gates, or guardrails, so that you block if there is a vulnerability, for example, in certain code or certain pull request or whatever. Your CI/CD pipeline, which you have created, has a responsibility to block that change. And developer will then be forced to make a change and fix that issue, and then only then the CI/CD pipeline will allow it to push into production. So these kind of things are also there, and this is something which you all must know before you know anything else. So that's what Jenkins is for, right? That's what GitHub and that's what GitLab is for. And there are many such tools. Even AWS has a lot of such tools. I forgot the name of the CI/CD tool chain which AWS provides is something called as AWS Code Star or something. So that is something which you all must know. All right, I have come to the end of the question. Now I'll open the floor, guys. I open it for you guys to speak. I have told you what I understood so far, and I have also kind of explained in brief what it is which I think you must know. I've tried to explain a few things here and there, but really the floor is now open for you to speak, to tell me what is it which you lack, what is it which you want to know, and how we proceed with it. Anyone?
Hi, sir.
No
This
one?
is Nikita from
Okay.
AWS batch. So basically, we understood the basics of CI/CD pipeline, but we wanted to do the project in which all the tools are used.
Okay,
So we
let me
wanted
do
to do
one.
that.
Okay, let me go to Miro. I'll write it also. Okay.
Yeah.
So you are saying you have exposure to all the tools, right? You're
Not
saying
Kubernetes yet.
okay, exposure to tools are there, but you want to do a project,
Yeah.
and that project will do what?
So we wanted to know the exact live project, like in real time, how we will use all the
How
tools.
a live project works wherein using all the tools. Okay.
I mean, whichever tools are required.
Okay, fine.
Yeah.
It's okay. Good. What else? Anyone else? Mhm. Yes. Yes, Rahul.
Yeah, actually, we have completed AWS tool, but still pending with this this in layout. We just completed Docker and GitHub. Still pending with all other applications.
So you're saying your voice is not very clear, but if I could make out, you are saying Docker and GitHub is what you used. AWS basics you have done.
Yes, yes.
Okay. So more or less you are trying to say the same thing that what Nikita was saying.
Yeah, like that, but they have completed all the other things. So we have still pending with them.
Okay. So I think there are two batches here. If you have done more, if you have done less, I think that's what you're trying to say, huh?
Yes, yes.
Okay. If I conclude this, this is just my point, just to understand. If I conclude that the overall objective is to get a job, of course that's our objective. I mean, there's no doubt about it. But is there someone here who says, no, my objective is to first get an AWS certification and then job?
No, sir.
Okay. Anyone here who says, no, I want to do certification and then the DevOps part? No, right? Why I'm saying this is because AWS certification preparation is entirely different versus what you guys are asking me based on the form I have read. Based on this, what I understood is you guys are more inclined towards getting a job and learning the tool chain rather focusing entirely on certification. Of course, while we run DevOps things or tool chain, we will be using a lot of AWS services. For example, we will be using AWS EKS, Elastic Kubernetes Service. Maybe we can use AWS Fargate. All those things we will use, but that is again something which we are using it. We are not preparing for AWS certification per se. This is what I'm trying to highlight. So when I will prepare my content, my sessions, I will not be focusing on the certifications part. Are you guys okay with it?
Yes, sir.
Yes, sir. Okay.
Yes, sir.
Okay, that's
Yes,
good
sir.
then. All right. What else? What else you want to tell me? Anything else? No?
Yes, sir. Actually, we want to, our basics are not clear, like how to write a CI/CD pipeline and how the tools are used. So basic concept of the DevOps tools are not clear. That's that we want to learn.
Okay, basic concepts are not clear on, for example, CI/CD pipeline. So if I say,
Right.
okay, that's a good thing. So if I say, it's an open question to everyone. If I say you have to create a CI/CD pipeline where you will go and I will give you a, let's say, a code, an API code, let's say Spring Boot microservice code, and I'll say this is the code, guys. I'm keeping it in GitHub, for example, and you have to write a CI/CD pipeline for it so that you can deploy. Okay, not CD, forget CD. I'll say just do a CI. That means use this API source code to build it, do all the necessary checks, and convert it into a Docker image, Dockerize it, and push it into a registry. If I just say this, okay, use whatever tool you want to use. You want to use Jenkins, GitLab, GitHub, whatever. How many of you are comfortable today at this moment in doing this?
Actually, Akash, we have not done anything of this sort. We've not
Oh,
done
you're not done? Okay. You're saying never created a CI/CD or a CI pipeline. CD is anyway long short. So you guys have never created a CI pipeline. This is what you're trying to say. Okay. Have you guys ever seen a microservice? Have you ever created a microservice?
No, sir.
No.
We've not done microservice, serverless. We've not done any of these.
Sir, we only, the Vedant sir only taught us about Maven, Docker, and GitHub.
So when you say
GitHub.
Maven of what? Like Maven is a project build system, right? So what were you building with Maven? You must be building an API with Maven, right? So you're saying
No,
you have
sir.
never.
No,
No,
we
sir.
only learned the 4 commands and
In
we only tried it. That's it.
build a war file.
Okay, fine. Good information, guys. This is what I wanted because I want to prepare, right? I'm not prepared at the moment. If you ask me, give me a lecture today, I don't know what to tell, right? I haven't prepared because as a trainer, I also have to do some preparation. And I can only do preparation before the class if I know what to teach in that class. I am right now fully unprepared. And that's why I'm collecting this information so that I know what exactly I need to tell you. So CI/CD pipeline, that's pretty basic, guys. CI/CD pipeline is pretty basic for you to know, okay? Instead of learning serverless and this and that, we need to know what is a microservice first, because you are supposed to deploy a microservice. If you don't know what is a microservice and how to create microservice, what the hell will you go and deploy, right? What the hell will you go and build? So now you're saying you have built a war file, which is again, there must be a package which you have built. Good, that you have some exposure, I understand, but not the full. Because war file is just a packaging of a Java project. It doesn't run on its own. It has to be deployed somewhere. It has, so we have to understand the structure of it also, because we want to run some test as well there. Okay, fine. Never created a CI pipeline, done some Maven things. By the way, how long this batch was running for you guys? The other chap, how long he was training you?
So
8
from
months, sir.
November, 8 months almost.
November. Yes, sir.
Oh, okay. It's quite a lot of duration. 8 months duration. So he
And
must
3
have told
months.
you something, right? I mean, okay, fine. I mean, you don't know these things. What it is which he taught you then?
Sir, two
He,
batches are mixes here. Means some are from 2-3 months back, and we are from 8 months back.
Yes,
So
So
sir.
we
in
know
from
the
8
basic of
months,
CI/CD. We
yeah,
can,
yeah.
we can
Hmm.
deploy it on registry and
Okay,
push
which is good.
also. But I
Okay.
think some are from previous batch, 2 or 3 months back.
We started in July, June. of-
Yes, sir. We are from 2 or 3 months batch, 3 month batch,
Yeah.
and we only know about AWS basics, Docker, some basic of Docker, GitHub, and Maven.
Okay,
That's it.
good. Okay, let's do checks now. Okay, enough of talk. Now, whoever is the brilliant in your class, right? Anyone can speak on it. Tell me, let's create the CI/CD pipeline stages. Okay, when you say we have done CI/CD pipeline. Okay, let me write it here. Come on. Text. Why it is like this? I don't know. Maybe just a sticky note. I want to ask you guys, tell me the stages we have in a CI/CD pipeline. Let's start with this. Who can tell me? And I'll draw the first block. Okay, I'll draw the first block. The first block is I have a source code. Right? This is the first block I am creating. I have a source code in let's say GitHub repo. Right. What is the next stage typically we have in a CI/CD pipeline? Who can tell?
We'll create a Jenkins pipeline. We'll pull the code. We will build it.
Build?
Build and test it using Maven.
Build using Maven. Okay.
Actually, Akash, I think we have to start with what is a CI/CD pipeline actually? That's where we start from.
Okay, so let's do it this way. No, so we all are sitting together and we are trying to create our CI/CD pipeline. So I'm not talking about the tools. I'm talking about what are the stages. You can use Jenkins, GitHub, GitLab, Travis, Circle CI. It doesn't matter. But the stages of a CI/CD pipeline are still constant. That is something which has to be there, and that's what you will configure in the Jenkins file or Groovy file or YAML file. Doesn't matter. Right now, what I have is source code in GitHub repo. And now you have told me that the next stage which will happen is pull that code from there, check out the Git repository and build using Maven, right? Cool enough. What is the next
Yes, sir.
what is the next stage here?
Test.
Test.
We have
Test.
to test it.
What kind of test?
So unit testing, I believe.
Okay, good. So let's say unit test. Fine. What else?
So code analysis.
Code analysis. Let's say we call this as SAST. It's called a security application tests. SAST, where let's say you're using Sonar or whatever, right? So static code analysis. Let's call this static code analysis. Fine. Then
Deploy.
Deploy.
deploy. Okay. You said deploy. Okay. So this is pretty basic. Okay. Let me show you. I have actually created another diagram because this is something which I always thought I would start with. I'll open Miro again and I will open my stuff. Okay. So this is what I feel a typical DevOps pipeline should be. And this is, again, I'm saying this is not exhaustive. There can be a lot of things which can happen here. This is just a simple one. And you guys have told me that we have source code, build, unit test, and then you're directly jumping to deploy to production. And then I didn't actually ask what do you mean by deploy, where you deploy it, because you never just directly go and deploy it to a prod. You have to deploy somewhere first. Then you run some more tests, some integration tests in an integrated environment, right? So you guys have kind of missed all those things. So this is something like let's start with this, okay? Because what else otherwise we will do in today's session. Let's start with CI/CD pipeline. Let's try to investigate the stages there. Fine. Source code, you can keep it anywhere, primarily in Git repository. You will go and build it. Now, when we say build, it is always dependent on what kind of source code you have. If it's a Java source code, you will write a build command for Java, which let's say is Maven. If it's a Node.js application, then you will use npm. If it is something else, if it is Python, you will use pip or something to build it or something like that. So build is again a generic term, but there can be different tools you can use to deploy it. And that's why I'm saying you need to understand what kind of different source codes are possible. Okay, so you need to know that, because if you are a release engineer, and I think I've created another thing here, job of a release engineer. Okay, what is job of a release engineer? Let's say you are a release engineer who is basically responsible for making sure that there is a point A where you have source code, and from point A to point B, you can deploy it, but not directly. By making sure everything is, first of all, efficient. That's a single pipeline which runs and deploys, no manual intervention. That's, of course, is called as automation, and that is important, but you cannot compromise on security, right? So there has to be a lot of checks in between, lot of merge requests, lot of pull request reviews, code coverage checks, uh, security checks of different nature. Security check includes SAS, static code analysis. It require DAST, which is dynamic application security testing. Then comes the vulnerability checks in the dependencies, because dependencies which you are using or the developer is using can have a lot of vulnerabilities because they are open source. I think if you have heard recently, not recently, at least 6 months back, there was an open vulnerability which was released called as log4j. I'm not sure if you have heard of it, but it was pretty problematic because a lot of companies and their developers used to use that open source library, and then out of the blue, the US Defense Department said there's a huge vulnerability here, and then all the companies have to go and remove it, and then have to upgrade the versions, right? And at the same time, release engineer also have to create a guardrail for it, that if this has this vulnerability, they have to stop it. They have to block it. So a lot of checks has to happen here within it. That's what I'm trying to say. Different kind of vulnerabilities you have to check. Then comes the container. Container can also be vulnerable. A container-based OS image can be vulnerable. It can have loopholes. So your job is also to scan it, right? If I come back quickly here. So once you do unit tests are not written by you. Unit tests are written by these guys. And all of this is not entirely written by you. They are the one who written by the people who have developed the software. But these checks are something which is your responsibility, right? So SAST, you will put here. You can use the most famous tool around SAST is Sonar, which has a lot of quality gates of its own, different A, B, C, D things. I'm not sure. Have you guys used Sonar before? Have you been taught that, or you have tried
Yes,
it?
sir, we have used.
Yes, sir.
We have
Okay.
used. Yes, sir.
But sir,
Okay.
not taught. We
Yeah,
from
yeah.
YouTube.
Okay. Fine.
Sir, we are not getting anything.
Sorry, what?
Actually, we are kind of lost because we don't know where what we've not done anything past source code. I think we've just seen a source code in one of the projects. That's it. That was on GitHub, and
Okay.
that was it.
Okay, fine. I know a lot of disgruntled students here. It's okay. We'll try. See, I'll try my best, guys. Okay. I'll try to give you that exposure. As I said, I have created a
Start from
small
basics,
plan.
sir.
Yeah, I'll start from basic, but not really a theoretical basic. We will start with experiments. My objective is to start with experiments, and while
Right,
we
sir,
are
but
doing the experiments, sorry,
Yes,
go
but
on.
sir,
Yes, sir.
we
Yes, sir.
didn't know about the CI/CD and pipeline. We
We'll
don't
do
know
it.
what it is.
See, we will do all that. See, what I'm trying to say is, you guys need to learn tools, right? You know what tool is? A tool is something which can be learned when you use it, not by studying it. You see, you have X, which you use to cut a tree. And if you start studying about X, that what is the diameter, what is the length, and what is the size, and what is the sharpness, etc., it won't help you. What's going to help is you pick up the X and start hitting a tree, and that is the best way to learn. And that is what
Sorry,
we
sir, for
are going to try to
disturbing.
do. Yeah, go
Hello,
on.
sir.
Go on.
Sir, sorry for disturbing.
Yeah.
Actually, sir, are you comfortable with? Hello,
You're breaking. You're
Anand is
breaking.
there.
Yeah.
Hello.
Go on. You're breaking in between, but still go on.
सर एक्चुअली क्या होता है जब वेट सर जब सिखाते थे ना
हाँ.
तो वो सिर्फ मतलब वो बताते कि डॉकर्स कैसे इंस्टॉल करते हैं, ठीक है,
हाँ.
मतलब पूरा कैसे प्रोसेस होते हैं वो बताते थे, लेकिन उन्होंने ये नहीं बताया कि इसका यूज मतलब प्रोजेक्ट में कैसे करना है या फिर लाइव एरर्स जो आता है, इश्यूज जो आता है उसमें उसको कैसे यूज करना है। वो एक्चुअली हमको वो कॉन्सेप्ट चाहिए एक्चुअली, मतलब आपने डॉकर तो सिखाया है, मतलब डॉकर कैसे इंस्टॉल करते हैं उसका ये मतलब इम्प्लीमेंट कैसे करते हैं वो ठीक है, लेकिन इसके रिगार्डिंग जब प्रोजेक्ट जब आएगा तब उसमें उसका क्या मतलब वो यूज कैसे करना चाहिए, क्या इसका लिंक कैसा करना चाहिए, वो नहीं समझ में आ रहा है सर बेसिकली।
Okay, got it. See, I understood.
Hello.
Yes, go on.
Yes, sir. Sir, I think we know very basics of all the tools. Not more than that. Like we used to do like installation only, and when you used to start projects, he got stuck in it, and then it goes on for 2-3 weeks, and then he used to leave it. So I think we know very basics of all the tools. Not more than.
Okay.
Sir, एक बार आपने basics से start कर दीजिए।
No, sir, as
Okay.
like you said, no, theory is not important. Practical is very
Yes,
important.
exactly, sir. Theory we can do
Very-
ourselves.
We also
Sir,
want to.
but if we will not know about basic, so how can we perform the advanced?
No,
Okay.
I think sir will start with basic, but not with the theory part. I think which is very good.
Okay, so let's do one thing, guys. Let me take control now. Okay. I know there's a debate between basic and not basic, and I'm not going to tell you if I'm saying I start with the tool doesn't mean I'm not going to cover basic, right? So for example, what you're seeing right now is basic. What I'm trying to say, what I'm trying to talk about. I'm trying to talk about what are the stages, and we will build on top of it. So this is basic. This is pretty basic, right? And we will see how we go and implement it in an actual CI/CD pipeline. So and whenever I start with the tool, let's say we start with an experiment, we are going to cover basic there. Okay, it's just the approach is a bit different. Our approach is not really from ground up. Our approach is we'll pick a tool, we'll pick a problem, we'll not pick a tool. So I'll not say, hey, this is how you build a Docker image. I will not do that. I will create a problem. The problem is when you go to industry, when you go to a job, they will not ask you to, hey, can you install Docker on the system? That is not what you will be given. You will be given, this is the software, learn or make sure that you create a CI/CD pipeline for this so that it can be deployed to production. That is a problem statement. And to solve that problem statement, we'll try to pull in tools which can be used to solve that specific problem. That will be called as our experiment. Don't worry if you're not entirely getting what I'm trying to say. We'll do it. So have patience, right? Have patience. I'm going there. I'm not sure how much time we have today. I think we have 1 more hour. I think it's okay. So we will. I think let's start something today. I'll try to show certain things today. Maybe I'll show you a microservice. Let's start with microservice because you need to know what is a source code. So you need to see what is a microservice, how it runs, how it builds, how the tests are run, where are the unit tests are there, because you need to know before you deploy something. You need to know what you are building, right? So all those things you need to know. So let's start with that. I'll cover it today itself, and then we'll try to understand CI/CD pipeline. So let's start our engagement, you and me. Let's start with CI/CD pipelines. Okay, so we'll start with CI/CD pipeline, building a CI pipeline first, not the CD. Can you tell me in this whole thing what is the CI and what is the CD? Can you even tell me till what stage you have a CI and till what stage you have a CD? Okay, what is the difference between CI CD, guys? Can you tell me what is CI and CD?
Yes, sir. So CI means continuous integration, and CD's full form is continuous deployment. So
Okay.
basically, Jenkins is considered under the CI part, and the
CI part.
deployment part is basically the continuous delivery, deploying the
Jenkins, so you
artifact
say
into.
okay, so you are saying Jenkins is doing CI, fair enough. Who is doing CD then?
So I think Kubernetes.
Kubernetes will do CD. Okay, someone is saying, let me write it.
Sir, please
Interesting.
start from Jenkins and Kubernetes because sir not taught us that.
Okay, you have to give it to me, the decision where will I start from? Let's start from where I want you to start, and then we will take it forward. Fine. So we will start with CI/CD. We'll start with Jenkins, or we will start with something else, because Jenkins is something, it's not the only tool out there which can give you CI/CD capabilities. There's better tools, more modern tools there. All right. So we'll see where to start from. But let's start with this question first. So CI and CD. Okay, CI is done by Jenkins. CD is done by what? Someone said Kubernetes. Is it? Everyone agrees to this? Any suggestions?
Deployment is also done through Jenkins.
Huh?
Kubernetes is orchestration.
Hi Akash, sorry for disturbance,
Yeah.
but there is two batches actually, and one is old and one is new. So there is a huge difference between understanding. That's
I'm
why.
not judging you guys. I'm not judging at all.
Yeah, I know. Like we don't know
Okay.
what is Jenkins and Kubernetes.
Fine.
Right, sir, right.
It's all okay. It's all okay. I'm just asking. So if there's a CI, someone is saying Jenkins, whoever can answer it, it's all okay. So someone is saying CI, because this kind of interaction is important. If you know it, it's okay. If you don't know it, it's fine. I'm not judging at all. Okay, fine. Let's come back to the question. CI Jenkins. Now I think I heard someone saying that Kubernetes is for orchestration. So what CD is doing here? Who is doing CD?
So like a GitLab or Nexus repository where the artifacts are uploaded.
Okay. Okay, no, this is not right. First thing, Jenkins is a tool. So people who know it, good. People who don't know it, it's for them. CI and CD is a concept, that is continuous integration and continuous deployment. CI stops here. CI means that the source code which you have, and if a developer comes and creates a merge request, right, it goes through all the checks, and the source code is packaged and pushed with the right version. This is the point till CI concept happens. This is the end of CI stage. The moment deployment comes into picture, then the CD starts coming into picture as well. Okay, and it's CI and CD are not tool specific things. Jenkins can very well do CI and CD both. All you have to do is in Jenkins that you have to put a stage, and then it will start doing things. Okay. Nexus repository has nothing to do with CD. Nexus repository is something like this, where you can store your artifacts. So right now, if I am using a Dockerized thing, then I will just publish it into a Nexus repository. Again, guys, don't worry. Today is just an introduction session. Today, I told you I'm not prepared at all. I have not done my preparation. I have not created anything for any content for you to show. I am just talking today, right? So if I'm saying something which you feel is a bit advanced, don't worry. I'm going to cover it again when we start using it, when we start deploying it, when we start building it. We're going to use understand those concepts again. So don't feel left out. Don't feel that I'm jumping. I'm going with the people who are advanced, and I'm only talking in their terms and in their language, and you guys have just lost it. Don't worry at all. I'm going to cover all these things together again with basics and all. So have patience and don't worry. Fine. Okay. Nexus repository, as I was saying, is something where you store the artifacts, which is once it's built, this Docker push publishes in the Nexus repository or any registry system which you may use. So it's not about CD. It's nothing to do with CD. Now CI/CD can be done by 3 tools which are quite famous: Jenkins, GitHub, and GitLab. Now, if I may ask, when you said Jenkins, where did you really install it? Were you using an installed version of it, or you were using it on your local? Anyone here were using it on an AWS or an installed version of Jenkins? So everyone used it, configured on local?
No, not local, sir. We use it on
Okay.
server directly. We
Where?
install it.
Where?
We are not using locally.
So where
So
did you install
EC2.
Jenkins? Okay, you
EC2.
installed this
On
in
server,
EC2.
we directly install on server.
Okay, of course, this is only true for the advanced, not for the old. So don't worry, guy. New guys, don't worry. Old guys, okay. New guys, don't worry. Fine. Okay, then you have GitHub and then you have GitLab. Fine.
Sir,
Now,
don't know about GitLab. We know about the GitHub.
okay, you know about GitHub. Did you tried creating any CI/CD pipeline with GitHub before?
Yes.
Okay.
Basic
ones you have used. Okay.
yes.
Did you guys use GitLab?
No.
No, sir.
No, sir.
Okay. Okay, fine. All right. So this is, let me come back to what I was discussing. This is a typical CI/CD pipeline. You have different stages defined, source code, that source code will build during the build. There are certain tests which are written, which is unit tests. Then you have to put some compliance checks, code coverage, then you have SAST, and then you have some more secret detection. There is one more called as dependency scanning. Sonar does it for you, more or less, lot of things out of the box it gives you. Sonar Cube, the cloud Sonar Cube version of it. But there are also other tools. For example, in GitHub, there are different way of doing it. GitLab, they have different way of doing it. Jenkins doesn't have anything of its own. It's an open source project, so it doesn't have anything of its own. But GitHub and GitLab are cloud hosted, right? Jenkins is not cloud hosted. Jenkins is something which you install on your own on a typical EC2 machine, or you can install Jenkins on a Kubernetes cluster also, but that's an advanced use case, so we'll not go there. So either we can do it with Jenkins, or we can do it with GitHub, or we can do it with GitLab. Let me decide which is the right tool, and we'll start with that. So when we start with the actual CI/CD pipeline creation, either we are going to start with Jenkins, or we are going to start with GitLab. GitLab is more modern tool with many companies adopting it, and it comes with all the capabilities which you need, and it will make you do things a bit faster. So I will see what is best for us to start, because we have a specific duration of time where you have to cover a lot of things. And GitLab has everything out of the box. It has everything, all the things which we need in a typical CI/CD pipeline comes here, are already under GitLab. GitHub also has the same features. It's just Jenkins I'm a bit worried about, because Jenkins, then everyone has to install their own versions, and that may delay things. So we'll see, we'll decide which is the better one. Fine. But irrespective of what tool you will use, either use Jenkins, GitHub, GitLab, the stages remains constant. These stages have to be there, have to be configured exactly what it is there in the diagram. Exactly, it will look exactly similar, whatever, irrespective of whatever tool you're using. After these checks, and these are just scanners, these are not gates. The difference between gate and a scanner, can anyone tell me? I have just talked about it. Scanner, scanning, and quality gates. What is the difference between these two? Okay, again, new guy, old guy, don't worry. Whoever can tell, huh? I'm not judging. If you can tell, good. If you can't tell, fine. I'll explain anyway. What's the difference between scanning and quality gates? Not different. What is the relationship between these two?
Scanning is basically to go through something, and quality gates will tell you about whatever we are scanning. After scan, basically after scan, you can go to quality gates. Something on
Good.
those lines.
Yes, something like that.
Consider.
Good. Yes.
Verifying build.
Verify build. Okay, fine. Okay, I'll tell you. When you say scanning, that means you have put some scanners here. So when you say Sonar, right? Sonar does the scanning. That means whatever vulnerabilities, problems, issues you have in the code, it will scan it. but that's it. It will scan it, it will give you the report. That's it. Your code will still go here and go and deploy. Until and unless you have quality gates, there's no point of scanning, because you are not doing scanning just for the sake of scanning it. You are doing scanning so that you know that something is wrong, and then you put a quality gate, a check, a stop, a block. And if there is a problem, for example, there's a vulnerability of criticality level high critical level. Let's say you have that. When you have that, your pipeline should have this intelligence to block it then and there. That is what we call as quality gates. So we have to come up with scanning. Of course, you may have done it, you may not have done it, but you know that there's a sonar thing which scans. But you also have to configure either sonar or your pipeline or something so that you block it. That is called as quality gates. So in a typical CI/CD pipeline, you have scanners and you have quality gates as well. This happens, but this doesn't happen automatically. You have to configure it. You can configure it again, irrespective of any tool. You can use Jenkins, GitHub, GitLab, whatever, it doesn't matter. You can configure it. Fine. Then you have build Docker. So after you run this all on the source code, because by this point it is all source code. Here, all these are source code specific things. So code coverage. Anyone can tell me what is code coverage? Any idea? Anyone? Code coverage? Okay, so code coverage is something which comes from unit test. I'll show you. It comes from unit test, and it means it's a matrix which tells you how much tests or how much code is covered by unit tests. That means, is there a piece of code in your source code which is not covered? So that's how you calculate the code coverage. The good number is 100%. It's calculated in terms of percent. The good coverage is called as 100%, but anything above 80% is also generally acceptable in the industry. So if you have a source code and your test runs, and after test runs, there's an instrumentation which gets added there. See, I'm using a lot of words here. Huh? Don't worry if you don't know. I'm saying instrumentation, this and that. We'll come to that. We'll go to the depth. It is not the end of CI/CD pipeline. I'm just repeating this again and again because I think few of you have this fear that I am jumping on topics. I'm only catering to people who know things and not catering to people who are new. It's not that. Today is a first session, introduction session, and we are going to talk about everything in detail eventually when we actually implement it. For now, bear with me if I am jumping on things. Fine. So unit tests are when they execute. Within it, you get something called as code coverage, which tells you it's just a percentage number, which tells you how much code is covered by your tests. That's the metrics. And you can put a quality gate here saying, hey, if the test coverage, the code coverage, not test coverage, the code coverage, if the code coverage is below 80%, block the build. Okay, so this kind of quality gates are also there in industry. I'm telling you things which are happening in industry, guys. This is all happening in live projects. This is all live things happening. Okay, when we practice, we may not use that, but this is what happens, and I think we have to make ourselves accustomed to the idea and concept, and then try to implement it as well. Never mind. So now we are here. Then comes the build Docker. When build Docker happens, you are building the Docker, and then the Docker image is created. And when a Docker image is created, you have to scan it, because Docker image is nothing but a small machine which contains your code or compiled code. And Docker machine or Docker virtual machine which you have created, called as Docker image, can have vulnerabilities. The OS operating system level vulnerabilities, right? Because every Docker image contains a small version of an operating system. It can have different layers, and any layer can have a vulnerability. So you have to have a scanner to do that, or to check that scanner. Check that image, and then again put a quality gate there, right? You do a scanning here, but you also do a scanning here, and you also put a quality gate here. Okay, if something goes wrong here, you stop it, you block it. If nothing goes wrong, fine, you do a Docker push and then you deploy it into a SIT. And there can be different environments, right? I'm only assuming that let's assume that you have a small company and there you have just two environments, SIT environment, system integration environment, and you have, let's say, production environment, which is actual live environment. In reality, there are 5, in certain cases, there can be 5 environments as well. Okay, and each environment is for certain things. So usually it is something like dev environment, then it goes to staging environment, then it goes to SIT environment, then it goes to UAT environment, then it goes to production. So there's so many environments in place, right? For the sake of simplicity, because we don't want to have so many environments, for the sake of simplicity, we just saying deploy to a SIT, or you can say staging. This is also okay. Staging. Once you deploy here, then you have to run some automated tests, right? So there are difference between unit test and difference between an automated test or integration test. This runs before the code deploys, but this runs after the code is deployed, right? Once the code is deployed, you have written some types of integration tests, which will be more of a black box test, that is request response test. So let's say this is an API. So this will have code to deploy or to run or to call the API endpoints and see their response is good or not. And if any of these tests are failing, you do what? You do a quality gate there as well, right? So you say if anything of here which is failing, I will block it. So you need to put a quality gate here. You see at so many places you have to put quality gates. Let me shrink it, otherwise it's becoming too big. Quality gate and scanning. Okay, so here you have quality gate, here you have another quality gate, here you have another quality gate for tests. Then you have something called as test. This is dynamic application security test. This I think I should also mark as red because you have to put a quality gate here as well. That is, if this test fails, then also we don't want to move ahead. And then at last you have one more test. You have performance tests. If performance is degraded by the change, you say no, performance is not good, there is something wrong with it, so you block it here. And once everything is done, then you deploy to production. And all of this is a automatic thing. So from here, the moment a developer, can I put a developer here? All shapes. I say developer. Person. UML. Okay. Oh, it's asking for money. So it won't let me put a person here, I think. Okay, it's locked. Only the basic ones. Okay, I'll put maybe this. I'll say this is a person. So if this is a dev, oh God. Okay, a dev. This is a developer. Okay, with the moment developer pushes a code in the source code, the moment it pushes the code here, automatically a pipeline should run. Okay, now there are certain things. You as a release engineer are not responsible for source code, not responsible for unit tests. You're not responsible for writing integration tests. You're also not responsible for writing tests. You're also not responsible for writing performance tests. These are all written by different developers, different teams, maybe part of the same team, maybe different people. But your job is to define this structure and making sure that everyone follows the same structure, to make sure that scanning automatically happens, to make sure quality gates are put in place, to make sure that if quality gate is failed, a report is being sent to the stakeholders, whoever has done the push or whoever is the relevant people. Okay, this is your job. Your job is not really to write these tests, write these components. Your job is to configure them. Okay, so as a release engineer, your job is to configure these things there. Okay, questions, guys. I want to hear more from you now. Do you have any questions, doubts, concerns, anything you want to speak, whatever you have just talked about so far?
Sir, how do we know the run integration test fails? Like,
how do we know?
Is there any
Okay.
notification or like what?
It's a good question. So if you're using Jenkins or you're using GitHub or GitLab, they have a specific feature, right? This is inherent in any of the tools, that if it finds something failed, something with error within any stage, it marks the build as failed. It marks the stage as failed automatically. So when someone writes integration tests, there are different frameworks available for writing integration tests. There's something called as Selenium. There's something called as Cypress, right? There are tools which hits the URL, and if they seize, and they put some assertions also there. So if they say I have hit this URL, but in return I get error, there's error in the web page, then the test will fail. And when the test fails, the build fails. When the test fails, the stage fails. How come the stage knows about it? Automatically, because the way the tests are written, they are deemed with two state: either they will be pass or they will be failed. If they will be failed, Jenkins or GitLab stage mechanism has this intelligence that it can track if there is a failure. If there is a failure in the stage, it will mark the whole stage as failed, and things will automatically will not go forward. If something is failed, it will stop it here. Now, integration test, as I said, is not something which we write. When I say we, that means you being a release engineer or CI/CD engineer or DevOps engineer, you don't go and write integration tests. You only configure them. You configure your stage so that if test fails, the stage of the pipeline also fails. And that is something also which you don't have to do much, because Jenkins or GitLab has this intelligence that if something fails within the job, within that specific stage, the whole stage automatically says failed, and it won't go ahead. It will just block here. Okay, questions? Any more questions? Are you guys feeling bored? Am I covering things which is not making sense? Be blunt, be brutally honest, guys. I'm fine. I can take it.
So what is run DAST? Like dynamic something?
That's right. Okay. Let me show you in the Google. DAST. DAST. DAST means Dynamic Application Security Test. It is the process of analyzing a web application through the front end to find vulnerabilities through simulated attacks. Okay. So DAST actually happens when the application is deployed, and there are open frameworks to do that. Okay, there are open tools which can do the DAST things. There will be tool, and what that tool will do, it will already will have its own test cases within it. And what it will do is it will hit your browser or hit your web URL. And when it hits, it tries to exploit some already documented vulnerabilities or problems. And if those things are already there, it will say failed. Okay, so there are different kind of security tests. Okay, let me go back again here. There are different kind of tests, guys. So testing also is something which you guys need to understand. What is a test? What are different types of testing? When you say unit tests, it's low level tests, unit tests. In unit tests, you test classes, you test methods. Simple, right? Nothing rocket science. Integration test is all about testing the functionalities of the application. So you open the browser, you navigate to URL, and then you do certain thing. For example, if it's Amazon application, you go and search for product, search will happen, and then you validate whether search is functionality is working fine. So there are different kind of functional behaviors you will go and validate here. But there are also an aspect which is called as security testing. The security testing, the objective of security testing is that by doing that, you make sure that the application which you have is not open to attacks. Okay, so there are different attacks possible. Okay, let me show you that also. OWASP top 10. Have you guys seen this before? Have you guys seen this? Have you guys visited this website before?
No, sir. No, sir.
Okay, this is something which you guys must go and read. So OWASP is an international organization. You see, it's an org. It's an international organization who tracks the trends in security vulnerabilities. And they are saying they are top 10 web application security risks, right? These are the ones. So injection, broken access control, cryptography failures, injection, insecure design, secure misconfiguration vulnerabilities of the components, authentication identification, software integrity failure, logging monitoring failure, server-side request forgery. So whatever scams you guys hear about, right? Whatever hacking which happens, most of them comes under top 10 of these. 90% comes here. Okay. For example, right now the common hacking mechanism is like someone calling you, hey, I am from this and can you please give me your token, sorry, give me OTP, and that's social engineering. That's different kind of scam, right? That's actually scamming. But these are something which is kind of loopholes in the application, right? Which developers are, whatever developer is writing, there are loopholes which he's introducing, which a hacker can exploit. So hacker is not intelligent. Hacker doesn't break the system. Hackers always exploit the open loopholes. It's the exploitation of the existing vulnerabilities is what he does. He's not intelligent. He's never this guy, hey, I will do something so intelligent no one is aware about. Of course, there are such people who keep doing that. They are actually super intelligent, of course. But there are also lot of majority of the hackers exploit the existing vulnerabilities which you have. So there is a documented list which OWASP has, and they keep on updating it based on the new data they get. And they keep on updating it, and they have created this top 10 security risks. They're saying that if you have these open vulnerabilities in your system, and if you don't take charge and don't fix them, then any hacker on his wish can exploit your system. Okay. So how this is relevant to us? Okay. Of course, you guys have to read about it. Please go and read about it. I will send this link again. But how does it matter? It matters to us as a release engineer is to make sure that this developer is not doing stupid things. This developer is not introducing any open source library or anything which already has an vulnerability which a hacker can exploit. That's why as a release engineer, it's our responsibility, duty to make sure that we do all the known mechanism to check the source code. So SAST is one of the way. Dependency scanning is another way. Docker scanning is another way, right? These are sort of static analysis. All of this comes under static. Static means the code is ruka hua code hai, okay? Ruka hua hai, static hai. So you go and check the static things first. So SAST is again, you check all the lines, wahan galti to nahi hai. Then you go and check whatever dependencies, because koi bhi developer hai, he will not go and write everything on its own. He will use lot of libraries, external open source libraries. And when you use those libraries, you have to scan those. These are called as dependencies, and you have to scan those dependencies. Okay. Then the Docker part, Docker images, because when you create a Docker image, you always use a base image. If you have learned Docker, if you have gone through just the first lesson on Docker, the Docker file, on top of it, you always have a statement called as from Alpine 562, from this, from that, from Node.js, from Java 8, Maven, something like that. So that means you are using a base image. What if that base image has a vulnerability? So that you have to check. Right? So these are all under static things. Now comes the test. These are more about dynamic application security test, right? So your application is now deployed. Now, once it's deployed, you may have more vulnerabilities there which you have not checked here, because here the code was static. It was not running. What if there is also different kinds of vulnerabilities which only can be caught when the application is running? That can only happen when you run the application and then you run some tests. This is called as test, dynamic application security test, right? So if I go to this link, see, it's telling you different kinds of application tests, security tests you can do, right? Static SAST, this is called a SAST. This is all what Sonar does. Then you have dynamic application security tests. Okay, so these two are something which is very, very important, which you go and must add in your pipelines, right? So there's the different kinds of things, vulnerabilities it can do. So SQL injections, cross-site scripting, right? These kind of things cannot be validated or cannot be caught in SaaS things, cannot be caught in scanning, dependency scanning, security scanning, static code and scanning, Docker scanning. You cannot catch these kind of vulnerabilities of SQL injection. They can only be caught when the application is running, and that's why you need test also. Okay, I think there is an open source tool for OWASP from OWASP, which is Wireshark. Is it Wireshark? Wireshark. It is a test tool, or it was, let me quickly check. This is a vulnerability scanning tool. I have to check. So whenever we add this, we're going to learn this. Basically, we're going to go through it as well. So don't worry. Yeah, it's for dynamic application security test tools. I think you will find an Wireshark here. Wireshark, Wireshark. No Wireshark here. Okay, forgot the name then. Not Wireshark. Z attack proxy, vscan. These are the list of tools which OWASP is saying you can use. It was a very good tool. I forgot the name now. Called TK card screen. Insight, wrapper escape. Okay, let's not waste time then. Okay. All right. So let me go back. We deviated a bit, but yeah. So that's test. Did I make myself clear on test?
Yeah. Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. And guys, whatever I'm telling you is a industry standard enterprise level stuff. Okay. Because the pipeline which you told me had 3 stages. When I asked you guys, tell me CI/CD pipeline, you told me 3 stages. That's not it. There are more stages. This is the minimum stages you need to have, and there can be more based on the security risk levels and things in your own org. But this is enterprise level CI/CD pipeline. This is how a CI/CD pipeline should look like. And this is what basically we are going to be creating eventually. Okay, what else? Any more questions in this space?
Sir, we are not getting anything, sir.
You're not getting anything?
Yes, sir. Because
Okay.
this is
So
very
basically, I think there are two batches. Like one is which started in November, one which in June
No,
or
I understand.
April.
I understand that. But what I'm telling
We
you
are not on the
basic.
same page, I guess.
But this is basic, guys. I mean, this is the basics building blocks of a CI/CD pipeline. So I cannot go more basic than this. So tell me,
sir,
what is it
but
which you didn't
we
get it?
don't know. We don't know why pipeline is created and what is CI/CD now, sir. How can we do?
Okay, so you
We
know
are not.
developer? You know what is a developer?
Yes, sir.
You know what is a source code?
Yes.
So when source code is built, you know what is a build?
Build
No,
means no, sir. Build means the var or jar
Right.
file
Correct.
creation.
Correct. So you build it. Then do you know what is a unit test?
No, sir. We don't know
Okay.
what is it.
Okay. So this is what I'm trying to say, guys. This is an introduction basic session. We are going to be creating everything from scratch. because when I give you an experiment, I'm going to be telling you exactly what we will go implement it. Even the advanced guys which you have here don't know Dash. They don't have ever seen, none of you I think have seen unit test. Many of you didn't see secret action. Maybe more, lot of you don't know about registry. So lot of people are not getting much here.
Yes,
But this
sir.
is the start point. Okay, so have patience. Have patience. Once we start with it, we will go through each and every stage and build it and create it on our own hands. So when you create it, then you will learn all automatically. Okay, right now, this is the guideline. This is the steps. So we go from here, then here, then here, then here, then here, then here, then here. I'm not expecting you guys know everything. I'm not saying that you understood everything or you must understand everything. But I am telling you a direction, but at least you know the direction now. That the direction is CI/CD pipeline. We have to create a CI/CD pipeline. That's the direction. I'm not talking about that you understand the end goal automatically today itself. That is the goal. To create a CI/CD pipeline is a goal. We may take 1 month to create it. But I am today telling you about the direction. Did you understand the direction? CI/CD क्या CI/CD है, हम किस डायरेक्शन में जाने वाले हैं? Did you guys at least understand that?
Yes.
Yes.
Yes, sir.
Yes, sir.
Who was the one who raised this originally? It was can you talk?
What, sir?
Did you raise it that you are not getting anything, Vinay?
Yes, sir.
So Vinay, don't worry. Vinay, हम क्या करेंगे? We will start with, देखो मैंने डायरेक्शन बताया. Do you understand the direction? हम CI/CD के डायरेक्शन में जाने वाले हैं. You understood it, right?
Yes, sir.
हाँ, so हम लोग slowly, gradually, each stage पे काम करेंगे. We will go and create our own source code. We'll see how we build it. Then we'll see how we run the unit test. फिर हम ये configure करेंगे. फिर we put the scanning, we put the quality gates, create the build, we'll generate the Docker build for it, we'll scan it. We'll do everything together, one by one, piece by piece, piece by piece.
Okay. But sir, I want to know why CI/CD pipeline is used.
Okay, good. So you asked that. Correct. Good question. Why CI/CD pipeline is used? Good question. Who can answer that before I start? Can anyone answer why CI/CD is used? Very basic question. I mean, I'm
For
really
automation.
being asked. For automation. Okay. For automation. Automation of what? What was happening? What is the problem it solves? Tell
So
me
to
that.
test the code before it is deployed into the production environment.
तो CI/CD क्यों चाहिए? मैं तो वैसे भी कर सकता हूँ ना. Why do you need CI/CD?
To reduce time in deployment.
So to create a flow.
Reduce time in deployment.
Teamwork efficiently.
Team
Different
efficiency.
teamwork.
Okay. Fine. Anything else?
Yes, the main concept of CI/CD is continuous integration, continuous delivery, and continuous deployment.
CI/CD and continuous deploy, continuous delivery. Good. Okay. तो मैं बताता हूँ आप लोगों को क्यों कर रहे हैं हमें. Okay. This is a good question, Vinay. I think. Thank you for this question.
Okay, sir.
What used to happen before? Let's try to solve that. Try to understand that. What used to happen before? Okay. So previously, there used to be a developer. Let's say he is a developer. He will go and write his code on his machine. Okay. Then he will go and build it. Okay. And then he will go and deploy it, or he will not deploy it. He will go and tell, there was a team called as ops team here. Okay. So there is an ops team and there's a dev team. There's always this wall between ops team and dev team. Okay. And dev team used to do what? Dev team used to build it locally, local build. And then he used to locally manually deploy. Okay. And then he will go and deploy, and sometimes he also did not deploy it. Sometimes वो बोलता था कि it will go and give it to dev. So this is a wall, and from top of this wall, it will say, hey, ops, you run it, and ops will go and deploy it. and then ops will get a problem in the production. तो production में कुछ problem आ गया, site नहीं चल रही या कुछ functionality नहीं, search नहीं चल रहा. So ops का बंदा क्या करेगा? Ops का बंदा बोलेगा अरे ये ops का बंदा है, ops dev. He's saying it's not working. So he will try to solve it. Doesn't work, then he will go back. He will go back to the dev again from top of this wall. कि यार तुम्हारा code नहीं चल रहा है. Something like that.
Akash, your voice is little bit feeble.
Can you hear me now?
Not properly.
Not properly. Is it
Yes,
for
sir.
everyone?
No, sir. Audible, you are audible.
Yes, sir.
Okay. Okay, so it's not from my side, Pooja or Neha, who raised it.
No, sir. I am audible, sir.
You are clearly audible.
Okay, good. Thank you. Okay, so this is what was happening, okay, from here to here. And what is the big problem here? You are losing time, right? Because when you are doing something manually and then emails and then bhai ye nahi chal raha, wo nahi chal raha, it used to take a lot of time. So let's say business ka banda aaya, let's say imagine in Amazon.com, there's a new mobile coming in, right? New mobile of certain, let's say, MI ka koi new model aaya, for example, right? Let's take that example. So MI will go and say, go to Flipkart, and MI will also go to Amazon. It will say, hey, I can do an exclusive launch of my product. My product is very famous. I will going to do exclusive launch of my product on your website. But when I do that, I need to have certain fields added in your website. मुझे Amazon के इस पेज पे ना, मेरे MI के पेज पे 5-6 नई fields चाहिए. How soon you can do it? अब अगर Amazon का मॉडल ये है जहाँ पे वो डेव बैठ के फिक्स कर रहा है एंड देन मैनुअली बिल्ड कर रहा है, देन इट इज गिविंग इट टू ऑप्स, एंड देन no one is making sure कि compliance checks हो रहे हैं कि नहीं, vulnerabilities check हो रहा है, no one is making sure of that. So everything is doing developer on his own, and then it's giving it to ops, and ops is doing certain things and something is not working. Then it go back to dev, it's not working. All that thing will take time. So it is called as lead time. What is lead time? Lead time is spelled as this. Lead time. Okay, lead time is the moment a business person comes. Business मतलब उसी project का एक बंदा होता है, वो business बंदा होता है. वो क्या करता है? It will take request, understand request, and his job is to tell it to dev कि भाई ये चाहिए मुझे आपके product में, right? The moment business comes with a request or requirement, the moment he comes with it, and the time it will take that request or requirement to go to the production environment, the time from here to here is called as lead time. ठीक है? अच्छा, आप based on your guess, how much time do you think Amazon takes for a small change to go from here to here? क्या लगता है आप लोगों को Amazon कितना टाइम लेता है अभी? Amazon के जो डेवलपर्स हैं उनके whatever process they have from here to here, the lead time, how much lead time usually they have, how many deployments they do they weekly deployments, do they do monthly deployments, or how? Anyone has a guess?
Weekly.
Okay, so 5 years back, 10 years back, the companies, उनका जो lead time था ना, lot of companies, it was 6 months. Someone's lead time was 1 year. Few were have 4 months. So that is what was there when DevOps wasn't there. When the CI/CD pipeline was not there, this was the lead time. That is a requirement coming from business to the production. It used to take 6 months and a lot of companies still there. A lot of companies have like 6 months lead time because the process, the mechanism for a new requirement to go from business to the production wasn't efficient. It is called as time to market. So this is a concept called as time to market. What is time to market? Time to market is the time it would take for a product to go into the market. So going back to the previous example, which is the MI says to Amazon, how much time will you take for my device, for my specific device to be launched on your platform? Because I need these 5 fields, so you cannot just put it there and it will just start selling. I need that specific time. How much time will you take? Amazon says, I will take 1 week to do this. and it will go back to Flipkart. How much time will you take to do that? Flipkart can say, I will take only 3 days to do it. So what is the difference between these two? Maybe Flipkart's way of CI/CD pipeline is more advanced. That means their system is more efficient and they can publish things from here to here in just 3 days. So to whom do you think MI will go for with its business, and who will lose money? In this case, Amazon will lose money, Flipkart will gain money, because time to market for Flipkart feature from developers, from production, from business to the developer to the production is less. So now again, going back to the original question, which when you asked, why we do CI/CD? Because we want to improve time to market. Because if you don't improve time to market, you lose money and you go out of business very soon. Okay, you know, Netflix is the leader in all this space. It is the one who created this, who is the first implementer of microservice architecture. Netflix is not a really a simple video streaming company. It is a tech company. It has really contributed a hell lot of different cutting edge state of the art architectures and libraries to the community. Netflix has the capability to do the deployments or 100 deployments per day, and you won't even notice. So आपका application चल रहा है Netflix, and you won't notice. आपने फिर refresh किया, a new feature will come there, right? And a lot of companies are there who take 6 months to do this, right? So see why we are doing this course. Understand why you guys are learning CI/CD, because everyone is not there. A lot of companies are still using the old model. A lot of companies have CI/CD pipeline, but they are not efficient. A lot of companies have CI/CD pipelines, but they don't have good quality checks, good processes they don't have, right? That's why you guys are getting trained in this, because there is a need in the industry. There's a need in the industry where we want these good release engineers who are capable of making sure that the software which the developer is writing goes to production in the minimal time with very good quality, and it has good quality gates and all those things. And that's why we are learning this. Okay, so the reason why you should have CI/CD pipeline, all the answers were right. So automation, yes. Reduce time to deployment, yes. Team efficiency, yes. CI/CD pipeline, delete deployment, yes. Lead time, which I added, reduce the lead time, time to market. Because if you don't do this, you lose money, the business lose money, right? क्योंकि फिर MI का पूरा product selling कहाँ होगा? Flipkart में होगा, right? Amazon will lose it. And the more such deals you lose, then you're gone, you're out of the business very soon. Okay, so the success of the organization is really depend on this DevOps revolution. If you are not doing it, not adopting DevOps cultural norms, not adopting good standards, then you will be thrown out of the business in next 2-3 years. A lot of companies have been thrown out of the window just because of this. And that's why all the companies are spending a lot of money for in this space. All right.
Means our CI/CD is a methodology by which we automate the process and reduce the time of process, right?
Amazing. Yes, you got it right. Exactly right, Minay. That's what CI/CD is for.
Okay.
Cool. Good. So guys, we need these kind of questions, right? You keep asking, keep challenging. This is the best way. This is called as churning. The churning of thoughts. Challenge, counter question. This is all very important for us, because I cannot tell you everything until you ask. I have a lot of information within me. Okay, I cannot narrate it, by my own. You have to get it out of me. So for that, you have to be right. So something like ChatGPT, right? ChatGPT is intelligent system. It cannot give you answers until you ask. You have to prompt ChatGPT to ask for the answer. Same thing you have to do with me. You have to ask. You have to prompt me, and that the best way to do this is asking questions. And no question is stupid questions. If you don't ask, you are a fool. So there's a saying, Japanese saying, if you ask, you may be fooled for one time, but if you don't ask, you will fool forever. So don't be a fool forever. Ask it. Ask that question. Okay. Okay, we are reaching towards the time. I have to show a few things then. Let me show you. Blah. Okay. I created this fancy diagram. Okay. I created this fancy diagram. Why I created this? I created this because I wanted to show you how we can start our stuff, because you know we don't have unlimited time, guys. First thing you understand, I don't have unlimited time. I have accepted this out of some urgency, right? I've accepted this. I don't also have unlimited time. I have a specific duration of time, and I have to be very crisp and clear so that I deliver the right information to you, right? So I cannot start with, hey, hi, this is how you'd install Docker. So I cannot start with Docker installations, right? I cannot start with very, very basic stuff. This is how you initialize int equal to 5 equal to 0, and then a and a equal to b. And I cannot do very, very basic stuff. So I assume you guys do it on your own. I will give you guides how to do it, and you try to do it on your own. But at the same time, I cannot miss out on a lot of things, because if I just start doing the advanced stuff, you won't get it. The same thing which Vinay was mentioning, right? You don't understand the concept, you will not be understand why we are doing it, right? What I thought is to divide our interactions, you and me, into experiments. Okay. So what I thought, let's start with the experiment. So I had divided what we want to do in next whatever months we have. I'm not sure how many months we have, maybe 2 months, 3 months. In all that period, how many experiments we can do and what we can do in those experiments, right? So I divided this into multiple experiments. Experiment 1, 2, 3, 4, 5, and this is not it. We can increase it based on what we want to do more. But based on the feedback I received here, I understand that you guys like experiments. And of course, now we have some new guys also. Fine, I will adjust the plan accordingly for you guys also. But we can try doing this in experiments, and all the theoretical basic stuff, we will try to learn while we do experiments, because as I mentioned in the beginning, the tool is something which is supposed to be used. Right? So when we use that tool, we can learn the concept then. It's not that we learn the concept. It's not like what we are used to study in college and schools in Indian system, right? That you learn, you read, and then just don't know how to use it. We are not going to do that. We are going to use the tool, and while we are using the tool, we will try to learn it, and we'll try to understand the basics of it. So if I jump into tool, don't immediately worry, hey, basic is not clear. Basic can be cleared when you do experiments. Okay, so I have divided this into experiments. What we're going to do, let's talk about the first experiment only for now. Let's not go through the rest of them. Let's just do the first one. The experiment 1, as I said, I understood that your CI/CD understanding is quite poor, and that is something which you must have. More than you know Kubernetes, more than anything, you must know what a CI/CD pipeline, because that's the start of everything. All DevOps, everything starts from developer's machine and how you build it. Right, so CI/CD is the basic, the first baby step you have to take towards the DevOps journey. So experiment 1 is CI pipeline. What we're going to do here, let me make it a bit bigger. So we are going to create a small Spring Boot microservice. We're going to create a small microservice, Spring Boot microservice. Anyone knows how to create it? Anyone at all? No, fine. Yeah, someone said, anyone?
The site is there, says Spring Boot, from that we can
Initializer, yeah, fine. We're going to do that again, fine. So if you don't know it, fine, we're going to start with that. We're going to create a small Spring Boot microservice. Again, this is not something what a DevOps engineer does. This is something which a developer does, but you need to know what developer do, and only then you can really understand in his terms, and then you can build it. So that's why we'll not go into detail of it, but we'll definitely see how to create a small microservice with 2 or 3 endpoints. Then we will store it in GitLab, GitHub, Jenkins, whatever. I'm thinking right now, I'm thinking of GitLab because it's really a very good modern tool which have a lot of features out of the box. So you don't have to worry on too many things. And it's also it's a tool which is on a rise. Many companies have started using GitLab. So GitLab has its own job market now. Okay, so I'm thinking of using GitLab, but I'm still deciding. And then there we are going to add all those stages. So we're going to add compliance stage, build stage, unit test stage, Docker build stage, Docker push stage. Then we are going to run it, run and monitor, and we are going to do some more experiments with it. The different ways of running. So a lot of tools chain will come here. The way you create Docker images and all those things, a lot of things will come here, and then we'll try to put in some quality gates with some policies. Again, a lot of things may not make sense now. I'm repeating this again and again. Don't worry, we are going to be building everything from scratch. I'm not going to show you a done product. I'm going to start very basic. I have to create myself first, right? If I want to tell you, I want to teach you something, I have to do my own experiments first, right? I haven't done that. So I have to start first. This is the first class we are having, this first interaction we are having. And every week I'm going to work on one experiment. So for example, this experiment 1, in this week, tomorrow onwards, I'm going to start with that. So I'm going to work on my things. I will create my microservice. Then I will create a Jenkins or GitLab, whatever pipeline. I'm going to add stages. And then I'm going to show that how I have done that step by step from very basic ground up. And the same thing you guys also have to repeat. So this is the pattern I think we should go into. And whatever theoretical stuff, whatever basic stuff which is needed, we are going to cover while we implement it. Okay. So whatever stuff which is basic theory, you don't understand why, how, what, whatever it is, while we are doing it, that's when we are going to cover. And then you have to also have to ask. I'll cover what I know, what I think I must tell you, and then you can complement the session with your questions. You can ask questions, and I will go into depth. Like someone asked DEST, I explained what DEST is, not in entirety, but at least I gave you some basic of it. So when we start implementing it, maybe then we will know more. Fine. So this is the learning objective here is CI/CD, GitLab, Jenkins, whatever tool we'll use. I think I'm going to use GitLab, but still Docker, build, tag, push, compliance framework, testing, test, Canico, JIB. Canico is and JIB is a tool by which you can create the Docker container, Docker image, without having to have any Docker file. So if you don't have a Docker file, you still want to create a container, you can create using Canico or JIB, which we'll talk about, which we'll see the implementation of it later. Okay, once this is done, then we can start with our Kubernetes stuff. We can play with Kubernetes, create Minikube, deploy service in Minikube. We'll say how kubectl. You guys use kubectl? Are familiar with it?
No.
No. Okay. Okay, so we'll try to learn basics of kubectl. We'll see deployments, pods, services, ingress, how they all work. Then we have another experiment. This time we will not use Minikube, we'll use kind cluster. I think you guys have not used it. Kind cluster is called as Kubernetes in Docker. So it's a way of you can spin up multiple nodes, multi-node Kubernetes cluster on your local machine, which gives a very, very different kind of learning because Minikube is simply one node cluster. Kind cluster you can use for deploying multi-node cluster on a single machine. It simulates that. So some more learning there. There's a tool called as Lens. Lens is a open tool which gives you, it looks like this. I can show you quickly. So Lens is a tool which you can use to see how the deployments is happening. Basically, this is how it looks. There can be different clusters. You can monitor with it. Different kinds of cluster you can monitor with it within each cluster. Okay, it's not there yet, but this is something which I would ask you to install, and you can use it for going into pods and checking the logs and doing shell inside the containers, running some commands and all those things you can do with it. And once these two are done, then we do the actual one. So we'll deploy a cluster onto the Kubernetes AWS EKS, and then we do the deployment of a sample application. And then we will do some infrastructure as code stuff using Terraform. So we'll use Terraform to deploy EC2. Now I must repeat it because then few of you will start raising questions. When I say I do this, it doesn't mean I'll just do this. This means I will tell you the basics. I'll tell you why we are doing this. We'll talk about what is infrastructure as code. We'll talk about what is Terraform, and then we start building. So we'll try to build up ground up, because now there are two batches involved, because originally I came here thinking that you have the basics, but now I think batches are merged. So I will try to go more in deeper. It will also help the advanced guys, because I think they also miss basics. So when I say I do this, it's not that I only do this. It means I will do the basic, but while we are actually implementing it. So the approach is different, but you're not losing on anything, right? So don't be worried. Then we do this, and then eventually we do this. So this CD is an extension of experiment 1 to 5. Actually, there are 6, but actually from 1 to 6, once we do all 1 to 6, then we do the CD part. That is, we'll go and add another stage here where we will have a CD as well. And then from the ground one, from the stage 1, which is the developer pushing the code, it will go through all the stages, and then it will go and deploy into our AWS EKS cluster using Helm chart. So this Helm charts thing also is something which we have to learn, which we will learn while we do the experiment. This is something very basic I created. I will have to perhaps divide this into multiple things, multiple experiments. And this is an experiment not only for you, it is for me, because I have to first do it. Once I have done it, then I will go ahead and then I'll teach you how I have done it. And while teaching that, I will also cover the basics. So this is the structure I think makes sense for me to teach you. And this is the approach I am taking. Any questions in this?
सर मीन्स आप जेंकिंस कुबरनेट ये पढ़ाओगे नहीं, मतलब ये नहीं पढ़ाओगे ना?
अब यहाँ पे 3 क्यूबरनेट्स नहीं दिख रहे हैं तुमको, देखो. Can't you see these 3 Kubernetes? We are going to create Kubernetes cluster, right?
Oh, sir, we don't know part of Kubernetes, मतलब kind of Kubernetes.
So we will do that, right? So these are the experiments. So I will start with Kubernetes. I will show you how to create a cluster. Then we will see how to configure it. Then we see how to deploy things there. What else do you think I'm missing? I mean, it's a good question. I'm not challenging the question. I'm saying, what is it which I'm missing here? Yeah. What is it which you think I'm not covering? Tell me that.
Means, sir, what is Kubernetes? How it is used? And you are saying play with K8s is a Kubernetes type of Kubernetes, right?
Mm-hmm.
Then how many type of Kubernetes are there?
There is only one type of Kubernetes. There's no different types of Kubernetes. It's one type. These two are local. I will deploy it local. This is on AWS. Then another can be on Azure, and the Kubernetes type is only one. There's no multiple type of Kubernetes.
Okay, then what is Kubernetes? What is used of Kubernetes?
So when we do this experiment, you can ask this question then, and then I'll explain it.
Okay, sir.
You see, so we are not changing the topics, we are changing the approach.
Okay, sir. And how it use? We have to use that.
Sorry, again?
How we have to use Kubernetes?
This is the experiment. How part is the experiment all about? Okay, how we have to use Kubernetes is all about experiment. That's what we are doing.
Okay.
Okay, see, it may not be the right plan, guys. It may not be the right plan, but this is the best I have. I cannot understand that. I cannot start with slides. I cannot start with a diagram saying, hey, this is how one by one you do, because it will take me 6 months. I don't have 6 months. You don't have 6 months. And you don't have to do PhD. You don't have to do one PhD on all the topics. right? You have to learn the breadth first very quickly. You have to understand the contextual understanding of the whole tool chain. Okay. This is how I learned it, right? This is how I learned it. I experimented. If I wanted to learn Kubernetes, of course I need theory. So I went to the internet, I opened the websites, read the tutorial, understood the basic. That's it. So reading the basics is something which you also have to do. Don't expect me to spoon feed you. Okay. You also have to learn, read, then come in the class, and then we talk about it.
Akash,
Okay.
one
Yes.
question I have.
Yes.
Can you just let us know what prerequisites we need, or or you might be expecting something from us, so that at least you can give some list about it, so that we can read on our own.
Good. Yeah, very good thing.
Something like
Very good thing. Okay. Let's talk about that.
that. Since I'm not from the CS background, so I'm still
Okay.
learning a lot of things about.
Okay.
That's why I'm.
Prerequisites. Okay. So I'm going to send some prerequisite material for you guys to read about it. Okay. But there are a few things which are top of my mind. Okay. Learn what DevOps is. They're pretty good material over internet. I will pass the links to you, but you guys should do some pre-reading on the topics. What is Kubernetes? What is not Kubernetes? Sorry. What is DevOps? What is CI/CD? What is SRE? Learn about SRE also. Site reliability engineering. What's that? Okay. A lot of articles around this. A lot of good stuff. Good material. I will also send some of the links. Okay. Then there are some technical things which I think you guys must know. Let's say technical prerequisites. Okay. You guys should know what YAML is. You guys should know what is some Linux commands would be good to have. Okay. Few things we cover, few things when I use those commands, then you will know what I'm doing, and then I explain it also when I'm using it. But it's better you know already about it. Docker, read about Docker, what Docker is, why we use it, what is containerization. See, what I don't want you guys is to come to class and say, I haven't read anything, you are the one who will teach me. It's not going to work, guys. Because I cannot cover everything step by step. We don't have that much time. I have very limited time, as I said, and I can only teach crisp information, and I can only talk about things which are very, very relevant, but not the very, very basic things. Basic things I expect you guys to read, and if you read it and then you come to class, my explanation will make sense to you, right? If you come to class with a blank mind, whatever I explain, you will not get it. So pre-reading is very, very important. When you do a pre-reading, doesn't mean that you have learned everything. It means that you have some keywords, some words, some structure in your mind, right? With lot of questions, loopholes, doubts. And then you come to class and then you ask those questions, and I will fill those gaps which you have in your understanding. Okay. So it's going to be a long journey, guys. It's going to be 2 months, maybe 3 months. I don't know. At least 2 months. I think it's so much experiments you have to do. One experiment per week. Still, it will be like 5-6 weeks we will going to spend with this, right? And I think CI/CD will going to take 2 weeks, 3 weeks, I think, for us. So it's going to a long time. You will have 6 days, 5 days in between the sessions. In those 5 weeks, I expect you guys to do experiments and do a lot of reading. Okay. So Suman, I'm not sure who asked the question, Sumant or Sumati. Yeah. So Sumant, right. So Sumant, if you are not from CS background, it still is fine, but you have to read more. I will publish some links in the group. Fine. I'll publish those links, and you just go into pre-reading. What is DevOps? What is CI/CD? What is SRE? What is a YAML file? Right? Learn few things about Java also if you can. Right? What is Java? What is Maven? I'm not expecting that you know everything and then come to class. You just read it. Once you read it, and then I explain it, then you can really get it. Otherwise, very difficult. Everything will start bouncing your heads. Okay. and that's what we don't want. So you guys have to spend at least 3 to 4 hours, perhaps. If you're not working, maybe you spend 2 hours per day. But if you're not working, spend 8 hours per day.
Yeah, I'm working.
If you're working, spend 2 hours then. At least 2 hours reading something.
Yeah.
Right? See, this is, I'll be honest, this is not easy, huh? This stuff which I'm talking about here, this is not easy stuff. Right? This takes time. Kubernetes is the most complex system we have in the IT infrastructure area. Very, very complex system. Okay, the complexity is so high that you really, first of all, you cannot just come and then start deploying things in Kubernetes. You really have to spend time with it. You have to have the habit of playing with it. There's no recipe that, okay, you do white 6, 7, 8 things and then, okay, then you're expert in Kubernetes. No, you cannot. Okay, so it's going to be challenging. The only way to solve a challenging problem is to stay with it. Okay, to spend time with it, and any amount of time is not enough. So if you say in a week 7-day period I spend 3 hours with it, not enough. You have to do it daily, at least 1 hour daily. At least if you're working, don't have time, whatever, spend at least 1 hour. Okay, on weekends spend 3 to 4 hours. If you're working, if you're having very difficulty in finding time, at least 10 hours per week you need to spend. If you
Akash,
spend
also,
less,
like, can we have some roadmap, like
I have this.
basic
I have
roadmap?
Sumant. I have this. I don't have any roadmap. I have this. I can streamline it. See, I'm also new like you. Huh? I'm also new. I'm a new trainer, for example. This is the first day for me with you. I mean, I've been with Vision IT from 8 years, but the first batch, first thing which I'm dealing with you, I don't have a plan. I have this. I have divided this into experiments. I'm not going to create PPTs. I'm going to create the live implementation of it, step by step, and you just follow my experiments. I think, see, my understanding, if you follow my experiments the way I'm telling you to do, I think you are good enough.
Okay.
Okay, so let's say I start with GitLab. I've opened a GitLab here. I will say, hey, let's create a new project. This is a new project. I will go new project. I click a new project here. Come on, it's loading. I create a blank project, dummy project. I'm just giving it dummy name. Okay, click public, create project. Okay, create project. Project is created, set up CI/CD pipeline. Configure pipeline. I have a pipeline here. Commit changes. Commit changes came here. I go to pipelines. The pipeline is running. This is how I'm going to tell you. So then I will going to teach you about each stages, what is happening behind the scene, what is pipelines, what is jobs. I'll tell you these things. So this is the way we are going to go, and we are going to check. These are the things. We'll check mark. Okay, we have done this. We have done this. Okay, we have done this. Compliance check done. Build stage done. Unit test stage done. We'll keep on doing these things from basic, deploying things, building things, putting stages, etc., one by one, and we'll complete the CI pipeline like this. So for me, this is a roadmap. For me, the roadmap is we'll do with the experiment 1, we go to experiment 2, we go to experiment 3, and this is not a complete list. I'm going to create more fine-grained experiments, small ones. Maybe we'll start with just basics of Kubernetes. I add experiment basics of Kubernetes. Then we just talk about the basics of Kubernetes maybe. So they are not going to be 6 experiments. Maybe they're going to be eventually 10, 15, 20 experiments, and each are actually a topic. So this is a roadmap I can offer you, Sumant.
Yeah, sure. Yeah, it is. I have a fair idea now. Like,
okay.
How we're going to proceed.
Okay.
Hello, sir.
Yes.
Sir, Terraform क्या होता है?
Good question. Terraform is a tool by which you can use it to deploy things. जैसे आपने AWS EC2 use किया है? नहीं किया. Yeah. Okay. So
Yeah.
how you create AWS EC2 instance? You go to Amazon and then you open console. You go to UI, create AWS EC2, give a memory, hard disk, VPC, IAM policy, security group. All this you create, and then you create an EC2 instance. EC2 instance is ready, right? But these are all manual steps. How can you automate it? So Terraform is to automate the infrastructure creation. So मैं क्या करूँगा? Terraform की एक script लिखूँगा. I will write a Terraform script, and there I will mention this EC2 instance in this security group and this region and this then VPC and everything. I will define policy, everything, and I will simply say Terraform apply. The moment I say Terraform apply on my local, automatically EC2 instance will be created on my cluster. So this is how I can maintain the state of the infrastructure which I want in a code. That's why it's called as infrastructure as code. And there's a tools for it. Ansible is one tool, Terraform is another one. Did I make myself clear?
Yes, sir. सर तो इसमें जो भी मतलब जो भी पूरा प्रोजेक्ट भी इसमें मतलब CI/CD भी होता है क्या दोनों साइमल्टेनियसली कि वन बाय वन करना पड़ता है?
ये भी good question ही है. There are two different things, right? One is CI/CD, which comes under release, build and release engineering, which only deals with CI/CD. But then there's another thing called as infrastructure part of it. The infrastructure part में Terraform वगैरह use होता है. Okay, so Terraform का primary use case है infrastructure, because आपका जो CI/CD है, जो भी CI/CD आपका कहीं पे deploy करेगा ना, वो जो deployment है वो कैसे होगा, right? Deployment can be done by CI/CD, but the place where it runs, Kubernetes has to run on an infrastructure. So you have to configure that infrastructure first. You can do it from UI. ब्राउजर में जाके चला दो, सॉरी Amazon AWS खोल के वहां पे you can go and configure it, but you can also automate it. So it's all about automation. CI/CD is about the deployment automation, and Terraform and all this is about infrastructure automation. So there are two parts to it: deployment automation, infrastructure automation. Deployment automation के लिए you need CI/CD, Jenkins, GitLab, GitHub, etc. For infrastructure automation, you need Terraform and Ansible.
Okay, sir.
Okay, cool, guys. I think we have extended. It's 10 minutes more. 2 hours. My throat is paining. I'm not used to taking 2 hours classes. So I think we have to end here. So what's next, right? Tomorrow, I'm going to start with this. Let's start with CI/CD, right? We are going to create a microservice, something similar to, I think I have it open somewhere.
Installing has already started. In order for the drivers to get installed properly, it is important not to interrupt the installing process.
So this is a simple microservice. It's a Docker API. It's a Spring Boot API. We don't have to learn Spring Boot at all, but we need to know what is an API. So I will show you I will start with what is an API, and that we see how we can write Docker files for it. I think I have written some Docker files here, pretty okayish Docker files. So we'll try to see how Docker file looks like and how Docker file can be used to Dockerize the application, and then how it will be pushed. So we'll try to do certain things from local, and then we try to add this into a CI/CD pipeline. Okay. So I'll start with here and see slowly, gradually, I will understand your levels also. There are two different people with different levels of understanding. Okay, so I will start with the basic things. And if you have doubts, go and please ask in tomorrow's call. But before we do the tomorrow's call, try to go through certain things. I will post in the group also. But to narrate something about Docker, something about REST APIs, something about CI/CD pipelines, just read these three things. I'll post some good links also for your benefit. All right. Thank you, everyone. See you again tomorrow. I think it should be same time. But if there is a change in time, maybe 1 hour up and or down, I'll update you.
Okay, sir.
Okay, sir. Thank you, sir.
Okay.
Sir, we need to install GitLab.
No, you don't have to install GitLab. That's the beauty of GitLab, that you don't have to install it. It's a cloud version. You can just create a GitLab account. So create a GitLab account. That's what you can also do.
Okay, okay.
It's very similar to GitHub. Okay. Thanks, everyone. Bye.
Thank you, sir.
Bye, sir.
Thank
Thank
you.
you, sir.